We had a comment on our recent video discussing weld buildup in shaft repair, where someone took great offense to using weld buildup for shaft repair, and they thought it was all a hack job like you see in those videos from India and Pakistan, and that's really not true. Those videos are a hack job, but there's a difference between taking a shaft like this that is broken and trying to weld it back together, which no one should ever do, and taking a shaft like this that has some minor wear from a bearing spinning and repairing it. The way you fix a part like this is to skim cut about 50 thou off, or whatever you need to get below the damage, weld up the entire surface, and cut it back down to size. There's a lot you need to be aware of in doing that to ensure it's done correctly. Pre and post heats, inner pass temperatures, what alloy the shaft is, and there are times when even with minor damage such as this, the correct answer is replacing a shaft. That's where it's important to have a reputable shop with experienced machinists who can determine what's the best way to fix your parts. For this axle spindle and hub assembly here, we've manufactured a new one. The ring for the seal protector is getting welded on at the end. We just have it set up in the mill right now to cut splines. There is a third type of shaft repair that you see done, especially on YouTube, quite a bit. You don't see it done much in industry because it doesn't work, and that is metal spray. There's a couple different systems. You see the eutectics a lot more in videos because they're a lot cheaper. These Metcos they're a better system, but they are a lot more money. These are for seal journals. These are not for bearing journals. You see people use them for bearing journals all the time. What they aren't showing you in that video is when that shaft comes back a week later because the material fell off underneath the bearing. Metal spray buildup has zero strength. It bonds to itself, it does not bond to the part. What you are relying on is forming a sintered ring that essentially shrink fits itself onto the shaft. For something like a seal, it works fine, and it can actually outlast a weld repair due to being able to use carbide powders and similar materials that wear better than the steel. Under a bearing, it has no strength at all, and it's guaranteed to fail. You can take a hammer, hit a journal sprayed with this, and it'll pop in half and fall off. We've redone many shafts that have been fixed that way over the years.